Hello class, and welcome to today's algebra lesson, which is about the intercepts of graphs. By the end of today's lesson, you will be able to identify intercepts, determine where functions are positive and negative, and solve equations by graphing. So we'll start with a few definitions here. First, the x-intercept is the x-coordinate where a graph crosses the x-axis. Remember, the x-axis is your horizontal axis. So you're looking for where the graph hits that horizontal axis, and it's always going to be in the form of number, comma, 0. So for example, if it was -5, 0, your x-intercept would be -5. Your y-intercept on the flip side then is the y-coordinate where the graph crosses the y-axis. Remember, your y-axis is the vertical axis. So the y-intercept is always going to be in the form of 0, number. So for example, if I had 0, 6, your y-intercept would have a value of 6. The positive portion of the graph is any part of the graph that lies above the x-axis. And on the flip side of that, the negative part of the graph is anything that lies below the x-axis. So we're going to start by dealing with the intercepts and the intervals. The first thing we want to do is identify the x and y intercepts. So when you are looking for the intercept, I'm going to start with the x. So we're looking at our horizontal axis and where the graph crosses it. So in this particular graph, your x-intercept would be at 3, 0, meaning your x-intercept is 3. Looking vertically now on the y-axis, your y-intercept is going to be at 0, 6, meaning your y-intercept is 6. Our next goal is to determine the intervals where the graph is positive and where the graph is negative. So starting with the positive portion, we are looking at the piece of the graph that is above the x-axis. This is the left side of my line. So it starts where the graph crosses the x-axis and is moving to the left. So in this case, the graph crossed the x-axis at 3, and moving to the left means that it's less than 3. So our positive part, our portion of the graph that is above the x-axis, is at x is less than 3. All of the values moving to the left. On the flip side of that then, our negative part of the graph, the piece that is below the x-axis, is the piece that is moving to the right. So that is our x values above 3. Go ahead and determine the x and y intercepts and the positive and negative parts of this graph on your own. So your x-intercept is at 8, 0. X-intercept of 8, y-intercept is at 0, -2, so the value of -2. The positive part starts at -8 and moves up, so to the right, and the negative part, that part is to the left, going down. When we have graphs, we can also have the nonlinear graphs. So things that do not form a straight line when they are on a graph. We can then look at our values, and nonlinear graphs may have more than one x-intercept. So in this case, our graph has 2 x-intercepts, so you would list both of them. The first one being at -4, and the second one being at +4. So for the nonlinear graphs, you may have more than one x-intercept. And then in this case, we also have a y-intercept, which is going to be at 0, -12. Looking at our positivity and negativity then, we have two different parts of the graph that are positive. This piece on the left and this piece on the right. So for the positive portion of your graph, the first piece are the x values that are smaller than -4. There's another option, so we're going to put in an or, the x values that are greater than 4. So those two pieces at the ends of our graph. The negative part then is what lies in between. So when we do this, we're going to write it as a compound and inequality. So we start at -4, which is our smallest value, go through all of the values that we possibly can, and then end up at 4. So this whole section of the graph is in the negative part of the graph. Go ahead and try this one on your own. Once again, we've got two x-intercepts at 1 and at 4. Our y-intercept was at -4. The positive portion this time is the part that is between. So we've got 1 is less than x is less than 4. And our negative portion is the part that is separate. X is less than 1 or x is greater than 4. Sometimes we need to be able to interpret these values within the context of the problem. So we're going to start by identifying them. So in this case, we have an x-intercept over here at 9, 0. Within the context of the problem then, I need to look at what the axis says. So this time now is 9 seconds and a height of 0. So the meaning then would be at 9 seconds, the ball reaches the ground. So that means after it is done flying in the air, the ball hits the ground after 9 seconds. Then I need to flip to looking at my y-intercept, which is at 0.4. Once again, we want to look at the context of our problem. So at time 0, aka at the start, the ball is 4 feet in the air. So we have to look and decide within the labels what that value means. So 4 feet in the air. So another example here of finding and interpreting values, I want you to start by finding the x-intercept and interpreting its meaning. So we've got 12:0, which means there are 0 people at the gym after it closes at 12 hours. Now go ahead and find the y-intercept and interpret that meaning. So we've got 0:20, which means when the gym opens or at the start of its hours, there are 20 people at the gym. We also can do this finding and interpreting of values when it is listed as a table as opposed to a graph. So we're still going to start by trying to find our intercept. In this case, our x-intercept is going to be at 40, 0. Looking at our labels here, with our x's being days and our balance or our dollar amount being y's, our interpretation would be that after 40 days, so after 40 of the x values, the balance is $0 or the account is empty. She's run out of money in this particular lunch account. Then, looking at our y-intercept, which in this problem is 0,150, means at the start of the year, so when there have been 0 days that have occurred the balance or the account has $150. So she starts out with that much money and is spending it over the course of the 40 days. I want you to try finding these values on your own, starting with the x-intercept and its meaning. So in this case, our x-intercept is 10-0, meaning after 10 trips to the movies, the gift card has run out of money. Now go ahead and find and interpret the y-intercept. So our y-intercept is 0.90, meaning the starting balance of the gift card was $90. The last thing we're looking at today is solving equations by graphing. When we solve by graphing, the first thing we need to do is make sure that our equation is set equal to 0. So in order to get that to happen, I'm going to subtract 1 from both sides, giving me 2x plus 6 is equal to 0. The reason we want it equal to 0 is because then it allows us to look at something, in this case, negative 2x plus 6 is equal to 0. That 0 is your x-intercept. Your x-axis. So we want it to be equal to 0 so we can compare the values to the x-axis. Then we're going to need some points to graph this other side of the equation. I always like to use the two simplest points. So I'm going to plug in 0 first. So I've got negative 2 times 0, which is 0 plus 6, gives me 6. So I've got a point at 0, 1, 2, 3, 4, 5, 6. That's my first point of the graph. And then I'm going to plug in 1. So I've got negative 2 times 1, which is negative 2, plus 6, which is 4. So my second point is over 1, up 1, 2, 3, and 4. Then you're going to want to use a straight edge. In this case, I can use my line tool. But when you are doing this on your paper, you are going to want to use a straight edge to make sure that you are connecting the graph so that you can see where your values intersect. Now, in order to make this a little bit more clear, I am going to delete this red line since it's a little thick, but you know that we want to look at where it intercepts that x-axis, which in this case is going to be 3, 0. This means your solution to the problem is x is equal to 3. So your x-intercepts are the solutions when you are looking at a graph. So once again, once you graph your problem, your x-intercept is your solution. Go ahead and try this one on your own. Once again, we start by getting it equal to 0. That orange line then, remember, is your y-axis, is that 0 marker. Finding and plugging in our values so that we can graph the other part of the line. I get 0, 8 and 1, 4, giving me my x-intercept at 2, 0. So my solution is x equals 2. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.